Hello, welcome to my channel. I've done more work on my program, as you will see. Quests have been implemented, the characters now have an inventory, and I have used class inheritance to create different kinds of NPCs. I'll go over all this in a moment. By the way, if you played through the last version of my program, then you may have discovered that there was an angry skeleton lurking in the pub. Before we begin, let me say a quick word about why I'm making this video. I wanted to find a fun project that was challenging but not too difficult. I wanted to encourage people to become programmers and to make their own games. But I would appreciate your feedback. What kind of Python videos would you like to watch? Please let me know in the comments. My videos now have an index, so if you would like to skip right to a particular section, you can. Here's the summary of the program so far, the changes that have been made to the program, setting up the inventory, implementing quests, class inheritance, and at the end, I will say a few things about what I would like to do in the next version of the program. So, a summary of the program so far. As I give the summary of my program, you should see a video, it's slightly speeded up, of me playing through the latest version of the game. As it stands now, the PC accepts 3 quests. The player will complete the quests and then turn them into NPCs in order to receive a reward. In addition, the player will be able to sell some of the items they have collected along the way. Here's a summary of some of the changes I have made to the program. I will go over many of these in more detail in what follows, but I would just like to let you know about what is different. First, I have implemented 5 new zones: Bridge, Swindon Pub, Provisioner, Cliffs, and Jeweler. So let's talk about the Bridge zone. I placed it just before the town of Swindon. I added this quest because the player needs to want something, otherwise why go on quests? A character, Wesley, a mercenary, tells the PC that he will reveal who the PC is. You will recall that the PC has lost their memories, for the low price of 100 gold. Since the PC is created with 30 gold, this creates a need for gold. Hopefully, this will give the player motivation to go on the quests I've created. In this version of the game, I have given programmers the ability to keep a PC in a particular area until, say, a certain quest has been solved or a necessary ingredient has been found. I can do this through the creation of either an action object or a persistent object. You can also use these classes to check whether the PC is sufficiently equipped for, say, a particular dungeon. This is accomplished by making sure that a particular item, for example, say a +1 Sword of Killing, is in the PC's inventory. Conversation, inventories, and quests. Oh my! Okay, so let's go over inventories, conversations, and quests. In my last video, I promised I would go over how I implemented the inventory system. It isn't all that difficult. I'll do an overview of the structure, it is fairly self-contained, and then talk about how I've implemented conversations and quests. Also, I've changed one of the maps. I've separated the map that keeps track of the player's position from the map that keeps track of the position of NPCs. It is neater and easier this way. Additionally, though I don't review this code, I've improved the move functions so that an NPC can get around small obstacles. Basically, if there is an obstacle in the way of the NPC, I choose one of the other 3 directions to move the NPC in. Then I, once again, try to move in the desired direction. It is a far from perfect algorithm, but it is easy to implement and it allows NPCs to get around small obstacles. I gave the dragon in the green lawn zone a new skin and enabled it to take shorter steps. Moved gold. I used to keep track of the amount of gold the PC had inside the player class. This proved awkward, so I made a gold coin and stored that in the player's inventory. Now the number of gold coins the player has represents the total amount of gold the PC possesses. By the way, you can make your own items using the input utility module that I've put on my GitHub, and I'll say more about that later. Keeping track of gold is more convenient this way because every time I want something from the inventory, it's going to be easy for me to access the number of gold coins the PC or NPC has. I removed the events class. I have swapped out the events class for the brand new Search Master Quests class. Since every quest has a history file associated with it, it is easy for me to peek at the history files of all the quests to see which quests have been accepted and which haven't. So I don't need an independent index to hold this information. It became redundant. I removed the dialogue speech class and the speech class. I replaced these with the conversation class and its helper classes. I'll go over that later, but you don't have to make this change. If the dialogue speech class was working for you, that's great. I made changes to the data file that stores the conversations. You will notice that I added a few more fields so that the information is better organized and therefore easier to access. I made some changes to the text dialog box. This displays all the time, and I thought it would be convenient to make it larger so I could accommodate more text, and this way I don't have to readjust the size of the window that is being displayed. I also changed the NPC class, and this is the biggest change in the program so far. The NPC class is now a parent class that is used by various child classes like Quest Giver NPC and Cell NPC. Additionally, I added a field to all NPC objects. It's called function. This field specifies what that NPC does and therefore which child class should be created. If that seems a bit vague, don't worry. I'll step through the code in a moment. Okay, enough of talking to you about what I'm going to talk to you about. Let's walk through the code. So let's talk about setting up the inventory. A PC needs somewhere to place healing potions, to store gold, to keep chocolate cake and iced cupcakes. There are two reasons why we need to create an inventory: to hold items for the PC and to hold items for an NPC. That said, a PC and an NPC are very different critters. The PC is played by a human, and that player has accumulated various items through interacting with the game. An NPC, on the other hand, needs to give or sell items to the player. But in the case of the NPC, it also needs to access items that the player does not have. So we have characters with different needs. But I didn't want two different classes. Thinking about it now, I might have used inheritance if I were to do it again, but it is what it is. Let's look at the constraints here. Since we want to create an inventory for the NPCs, the inventory class needs to know the relevant PC's name. This is because each and every NPC will have changed the PC in some way. The PC will lose hit points, have sold goods, and so on. Since the NPCs will also change because of their interactions with the PC, when we save these changes, we need to save them from the player's directory and not back to the master template. Therefore, each player character needs their own set of NPCs. To simplify things, at the moment all NPCs have access to all game items, but that will change in future versions. When it does, each NPC will have a subset of items to sell. NPCs in starting towns will have cheaper items of lower quality, while big towns will have more expensive items of high quality. Also, I think I might at some point limit the number of units they have for sale. So Alfred in Henry's game could very well run out of, say, bitter water, while another player playing another PC could still have a full supply. Because each player's version of the NPC will be unique, we need to know the player's name every time we access an NPC's inventory. But, and perhaps this is counterintuitive, we also need to know an NPC's name when we want to access the player's inventory. Let me explain. How do we store items in an inventory? Broadly speaking, there are two choices. First, store each item in the inventory. To find an item, you search for that item in the inventory. If that item isn't in the inventory, then that item isn't there. Second, store all items in every inventory, but indicate that a particular PC does not have a particular item in their inventory through the item count. If the number of units of, say, bitter water a PC has is 0, then they do not have any bitter water in their inventory, and that goes for NPCs as well. Which method should you use? Well, there are benefits and disadvantages to each. One of the disadvantages to using method 2 is that each PC only stores a lookup table. This means that each time an item is accessed, it must be looked up in the master list. It also means that whenever the master list is updated, that each lookup table for each PC must be updated. I chose the first option because I felt that, for me, it would be easier to debug. Also, there is less chance for an error to propagate to the inventories of all PCs or NPCs, but to each their own. There is no wrong way to do this. There are advantages and disadvantages to each. So it follows from all that, because we need the same information for both a PC and an NPC, the class needs to be told whether we want to create the inventory of a PC or the inventory of an NPC. So we pass through a third variable, and I've named this character type. As you would expect, the permissible character types are player and NPC. I store the values as a list in the constants module. We are almost finished looking at the initialization function. Before we leave though, let's look at the two object variables that do all the heavy lifting for our inventory class, consumables and weapons. These two object variables together compose the inventory. Consumables is pretty much what the name suggests. It is any item that can be used up. Weapons, I really need to pick another name for that class, holds all those items which will not be used up after use. For example, a sword is never going to be used up, at least not in this version of the game. I haven't implemented weapon decay. A flask of bitter water, though, will be used up. So a weapon will still be there after the player uses it, and a consumable is something that will not still be in the player's inventory after the PC uses it. I think weapons is a bad name for the weapons class because a gold coin isn't used up either. Okay, so let's look at how we populate these classes with data. If you want to create an inventory for the PC, then you form that file path. But if you want to create an inventory for an NPC, then you form the other file path. Simple. Now let's look at the weapons class. As with the consumables class, we form the relevant file path depending on whether we want the inventory to be that of a PC or an NPC. Let's go back to the inventory class. The next thing we do is call the readData function. This is a very simple function. All we do is call the real data function of the consumable and the weapons class. First, and I think I may have gone over this before, but it bears going over again, let's look at the readData file function in the utilities module. Here we make sure that there are no spaces before or after any of the lines, and that we've removed all the new line characters. In the second half of the function, we look at each line, separate it into a key value pair, and add that key value pair to a dictionary. Once a record has been completed, we add the dictionary object to a list object. We repeat doing that until the end of the file. Then the list containing all those dictionaries, one dictionary per record, is returned. This makes unpacking all that and reading it into a list easy. As you can see, we use a for loop to go through the list, and for each item of the list, all the items are going to be dictionary items, an object variable is created and stored. I put up the readData function from the weapons class there. Notice that the readData function in the weapons class is the same as for consumables, which we just looked at, so I won't go over it. Let's say that we want to get an item from the player's inventory. Here's that code. And we're going to look at the function getItemByName. This function is in class inventory. Outside of class inventory, nothing is known of the consumables and weapons classes. These classes are effectively private since they are only used by the inventory class. Given this, when we want to get an item from an inventory, we need to determine first whether that item is a consumable or a weapon. If it is neither, then none is returned. Okay, so now looking at getItemByName, this code is very simple. It is simply a for loop. I won't go over the getItemByName function in weapons because it is pretty much the same. I will go over just one more function from the inventory class because it is a wee bit more complex and has to do with implementing functionality I've discussed previously. This function is addItemByName. An item is added to the inventory when it is added to either the weapons inventory or the consumables inventory. So let's look at how we add an item to the consumables inventory. Let's walk through an example. Say we are adding the item bitter water. First we would check to see whether the inventory contained one or more units of bitter water. If so, then all we have to do is increase the units of bitter water by the desired number. However, if there are no units of bitter water in the inventory, then there will be nothing to increment. In that case, we read the item from a data file. In this case, the data file of the master file of all the consumables. And there you can see the code for the getRecord function I used in the utilities module. We read the data file in and look for the specified key that has the specified value. We then return that record. If no record is found, none is returned. When we have the desired record, we then create a new consumable object and then append that object to the list that contains all the object variables. The weapons class works exactly the same way. Okay, so that finishes my overview of the inventories class. In a moment, we will take a look at how quests are implemented. However, to do this, since a quest needs to be offered to a PC during a conversation, let's look first at conversations. So conversations. The conversation class is a graphical class. It is set up to create and populate a screen that will display a conversation between an NPC and the PC. Because of this, the class needs to have a sprite group and an initialization function in it Pygame for the relevant variables needed to display visual elements. I won't go over these since I have done that many times in my previous videos. So there you can see the conversation class. You will notice that a player name, NPC, zone name, and map name are required to create a conversation object. As we've just seen, we need the player's name and an NPC's name to read in the PC's inventory as well as an NPC's inventory. The NPC's name is also required for finding the correct quest, but for that we also need to know the zone name and the map name. This is because the quest templates are stored in the conversations directory that is kept with the map files in the zone directory. There are many different ways to implement a conversation. For instance, in earlier versions of this program, I stored all the quests in their own file, but keeping the quests with the maps makes more sense to me. For one thing, I found it easier to debug, and that is not a trivial consideration. The final variable we can pass in is conversation only. If this variable is set to false, then the conversation will involve a quest. However, if this variable is true, then there will be no quest offered. This information helps because then we know we don't have to bother looking for a quest reward. Clear as mud? If you have any questions, please leave a comment and ask. Implementing quests. We are going to talk about quests in a moment. In the read data function of the conversation class, we find a very important bit of code. Let's look at the initialization function of the class master quest. Here's what the quest file looks like. In retrospect, I should have titled these files with the name of an NPC and then quest rather than history, but I'm not going to go back and change that now. I'm not going to go over every field. They're fairly self-explanatory. I don't currently use all of them. For example, quest summary and quest display text aren't used, although I do think maybe I'll use them one day. I thought it would be easier to include them from the beginning than to insert them later, but let us go over what are two of the most important fields, quest accepted and quest completed. These fields are self-explanatory. Quest accepted is false if the quest has either not been presented to the PC or presented but not accepted. Naturally, if the quest was presented and accepted, then this field is set to true. As you would expect, if the PC turns in a quest, then quest completed is set to true. These two variables control which conversation file the program loads. Here are the possibilities. That is from the read data function in conversations. If quest completed is true, then we display the conversation completed text. If quest accepted is true, then we display the conversation accepted text. If both quest completed and quest accepted are false, then we display the conversation text. The logic behind this is that when a PC first comes across an NPC and engages in conversation, the NPC is going to offer the player a quest. If the player accepts the quest, then the next time the PC talks to the NPC, they need to get a different conversation. What I have done is given the PC a chance to turn in the quest or be reminded of what exactly they need to do to complete the quest. If the PC does finish the quest, then the next time they interact with the NPC, we use the quest completed text file, which thanks the player for completing the quest and offers a couple of other options. I haven't done this yet, but you could have the NPC offer to sell the PC something only after they completed a certain quest, as a kind of reward. With all that in mind, let's take a look at how conversations are begun. In the myclasses.py module, let's look at handle events. Specifically, let's look at the line else if event key equals Pygame H. As you can see, this code just says that if there is an NPC on the same tile as the PC, that some sort of action will be required, but which action occurs will depend on the function of the NPC. At present, I have coded for 9 functions. One of the most commonly used is that of the quest giver, so let's go over it. There's the code up on the screen. Here we are creating an object variable, reading in the relevant data, and then running the dialogue that plays out the conversation and solicits the player's input. Let's step through a conversation. So you'll notice here, and I'm showing the text file on the screen now, the index identifies a card, and there are usually several cards in a conversation. Then there's the prompt, and the prompt is just that, something that elicits the player to respond. Then we have the choice 1, choice 2, and choice 3 fields. At times I wish I could give the player more than 3 options, and sometimes I wish I could give the player only 1 option, but the coding for that would be much more complex, and I have limited time, so 3 choices it is. Whatever choice the player makes, 1, 2, or 3, the corresponding response is shown. For example, if the player chose 1, then response 1 will be shown. Next we see the fields to do 1, to do 2, and to do 3. The possible values for these fields are as follows: end conversation, continue, accepted, completed, buy, sell, take item. Also, there are some mixed commands where a command word is followed by a variable. For example, sell 3, buy 4, and so on. So far so good. Now let's look at the code that is triggered if end conversation is chosen. You can see that code up on the screen. You'll notice that stop looping is set to true. This will stop the dialog from being displayed and will return the player to the main program. When the command is given to end the conversation, we look to see whether anything is listed in the next 3 fields. If an item is listed, then that item is placed in the PC's inventory. Now let's look at the take item command. This command is straightforward. If an item is supplied in one of the item fields, item 1, item 2, or item 3, then the program places that item in the PC's inventory. So much the same thing happens as in end conversation, but this allows us to place the item in the inventory without ending the conversation. I think the rest of the commands are self-explanatory. If you have any questions, please do ask. So far we have looked at how to set up an inventory as well as how to implement quests. Now let's look at class inheritance. Class inheritance, how can I explain this? Someone much wiser than me once said that every bit of code should be the solution to a particular problem. I had a problem. I wanted to create an NPC, a bird, that randomly flies about unless the PC has wild blueberries in their backpack. If they do, and if the birds are close to them, then the birds freeze. The problem is that I didn't want to custom code this exception into the update function. One solution to this would have been to create a separate class for the birds. And I could have done that, but that would have involved a lot of code duplication. Another negative was that it would be difficult to easily spot the differences between the bird class and the NPC class because of all the redundant code. Of course, the solution here is to use inheritance, and that's what I did. I made the NPC class the parent class, and then I created child classes that implemented the parent class. Let's go over the Garrican NPCs. I called the child class the bird class Garrican NPC, so let's go over that class and talk about how I implemented the bluebirds in the 3 feathers quest. I gave each bird a blue feather, and by the way, this meant I had to create an item blue feather. I'll say more about that in a bit. Here is the initialization function for that class. Now, any data that the parent class NPC needs has to be given to the child class first. You can see that this is what I've done here, and there's a line from the initialization function. Now that our child class has access to the data the parent class needs, we give that data to the parent class. If we didn't do anything except put this line, the line containing the super function, in the initialization function, then the Garrican NPC class would be able to do everything the NPC class can do, but nothing else. Of course, we need it to do something else. Among other things, we want to teach our NPC to give our players a feather if they have one to give. So I added 3 fields: resource, number of resources, and gold. The resource specifies the name of an item, in this case blue feather, that the NPC can give to the player. The number of resources specifies how many items the NPC has. The gold field specifies how much gold the NPC has, if any. Notice that it would have been very easy to have the NPC randomly choose between several items and various amounts of gold. Okay, now let's look at the default action function of the child classes. Let's take a quick peek at the update function in my classes and see how this ties into the program. As with my previous version of the program, at every tick of the clock, if the NPC is not dead, then the NPC gets a chance to run their default action. In the case of some NPCs, such as quest giver NPCs, the only way they can be triggered is by the PC being on the same tile as the NPC and pressing H. So as you can see, they have no meaningful default action. However, the Garrican have a meaningful default action, so let's take a look at that. You can see here that we pass through 2 things: the obstacles in the game and the PC. We use the obstacles to make sure our Garrican do not fly through walls. Also, the Garrican need to know where the player is because they need to figure out how close they are to the player. That's the overview. As you can see, the first thing we do is see whether the player has wild blueberries in their backpack. If they do not, then we move the Garrican randomly. If the player does have wild blueberries in their backpack, then we calculate the distance between the player and the NPC if that distance is greater than 1.5. 1.5 is an arbitrarily chosen value. Please feel free to adjust it. Then the Garrican moves randomly. If not, though, if the Garrican is closer than that, then the Garrican does not move. It freezes. And as a result, the Garrican is very easy to click on, which was the point of all this. Since we don't want to change anything, we return none. Let's look at one more example. A child class that does return something is Mercenary NPC. Mercenaries are chatty critters, at least mine are. They run up to the player and have a conversation with him. Since the player's inventory may have changed during the course of the conversation, and so we need to update it in the My Classes module and send it back. Those are all the child classes I'm going to step through. If you would like me to step through any others, please let me know in the comments. Before I go on, I would like to say a word about my input utility module. I've included that in my GitHub repo. This small program automates certain tasks. Tasks such as adding an item or NPC to the game. If you would like to explore that program, just simply run the input utility module and you will see what it can do. Beware though, some of those names are just stubs for which I have not yet written the code. Now let's look at the consuming class, and this is in the graphics fauna module. We're almost done. There's only one more thing we need to go over. Specifically, we needed to change the load data function to reflect the fact that we now have a bunch of child classes. But fortunately, this was easy to do. As you can see, which class a record is read into depends upon the value of the function field. Here we see that Alfred has the value cell in the function field. So, going back to our code, we can see that this NPC's data would be read into the cell NPC class. We create a cell NPC object and then append this object to our list. For each function, we give a corresponding class. But it doesn't have to be a complex class. For instance, by NPC is just a stub. Okay, before I end this video, I want to talk a little bit about what I planned for the next one. In part 7 of my How to Create a Graphical RPG in Python and Pygame, I want to go over how to implement a quest chain. I'm really looking forward to this. I will set up 2 distinct quest lines. One has to do with the hero's central goal, their primary goal, of restoring their memories and rescuing the king. This quest line begins at the fortune tellers in East Haven. Another quest line has to do with becoming integrated back into society. You will notice that raccoons are constantly menacing the PC. In my part of the world where I live, we have many raccoons and they are very cute, but they can be a handful within the city. The second quest chain begins with the hero taking up the call to find out what has driven the raccoons out of their natural environment and into the town. Second, I plan to introduce a new, larger town, the town of East Haven. East Haven will have more NPCs to buy from and sell to, as well as several quest NPCs. And finally, as part of all that, I plan to introduce both new adventuring zones and new adventures. Also, as I have said, I included NPC raccoons in this edition, and their role is to badger the player, nipping at his heels, causing very minor damage. I did this for the atmosphere. As I mentioned, the hero will eventually be offered a quest to help rid the town of raccoons, and I thought it would be fun to make the problem more personal to the player. That's it. If something here has helped you, it would be great if you gave the video a like, since that really helps the channel. If you would like to be notified when my next video is published, please subscribe. Thank you for watching. Until the next video, good coding.